Today we will be talking about networking. I will be using basic sockets for connectivity due to the fact that the transactions will be signed in the client before they are distributed. So we don't really need any encryption on the actual socket itself. Each blockchain node is basically a server and client, so it hosts the blockchain, creates transactions, and distributes them throughout the network. So for each existing node, the program running your node basically will spin up a client and store it in its chain distribution list for when another node connects. It will send that distribution list to the new node. Here are the classes I will be explaining in this episode: INet, CServer, CClient, and the packet format. So here's basically how the networking will work. This is the first chain node, the first one that's ever spinned up. And then a new blockchain node is spinned up. Someone else wants to join the network. It connects to the network. Now this is simple. Then it starts synchronizing data, and then this one chain node can sign transactions and distribute. This one can sign its transactions and distribute, etc., etc. Now when a third node connects, it can connect to any of the nodes, which will have the distribution list. Basically right now there's two nodes on the distribution of the network. So basically that distribution list is shared back, and then it connects to the whole network. Now let's say another node spins up, connects to any of the nodes, distribution list is sent back, then it connects to this whole distribution, etc., etc. So to start out, I will be explaining this server class. Now, before I even explain this server class, I have to go to explain the INet interface. Now, what is the purpose of this interface I created? The purpose is that CServer and CClient will both be communicating data, and they need to have the same format. So I created this INet class, which they both inherit, you can see. And this INet class will have all the send and receivers, the sockets. So I don't have to go to, if I change something on the server, I have to go to the client and change it again. It's just to keep everything well structured. So let's start with the INet class. So first, the INet class. The INet class first element is this socket handle that is returned by create socket. And these are the two main functions that will be. This is to receive a packet of data. This one will be to send the same format, packet of data. This is a chunk size. We can manipulate this if we ever need, but this is a very acceptable chunk data size. Since we can't just read, if it's a big data, we can't just read the whole thing direct in one shot from the socket. We have to go chunk by chunk. This is only used in send data and receiving data. And these functions are just to handle sending data types as their binary net format, unsigned integer, signed integer, etc., etc. And the data packet. So for sending the actual data, which will vary depending on the message type. In e-message type, I have all the message types up to now, which would be a ping, just to keep the data flowing, acknowledge error, and two actions. Now, when I send the data or receive the data, given that I send the size and receive the size in the packet, if the size is not 0, meaning we will be receiving data, then this function is called. So this is where it receives it by chunks. As you can see, whoops, it's big. And fills in the data. Now this allocates the data on the this pointer. So then the packet, itself, I set this flag to say the packet will be tracking the allocator. This means when the packet is destroy data is called, it will deallocate that data. Now there's other scenarios where the data will be locally allocated inside the scope of the function. Here's an example of one on CClient. I set the data, which was allocated in hostname. It's already allocated in the chain. So, but basically I'm setting this data, which I don't need to track because the chain object's already tracking it. So this one doesn't really require me to call destroy data. Even if I call destroy data, if this flag is not set, it won't even destroy it. Sometimes it's better just to call it just in case. But that's another scenario. Now here is the CServer class. CServer class consists of a worker thread, which will be the listener, and a thread for each of the individual clients that will be connected. So starting out with let's go here. Start the entry point, that would be start. So here in start is where the listener socket is created. Here I am setting the address to blank. I'm blanking it out. memset 0 and then assigning AF INet. This is for a TCP socket. The port, which we have to, this function here, HTONS, basically grabs the data type. This will be a short data type in the machine level and converts it to a net port, meaning this is a network acceptable number. And then here this basically says listen to any client that will be incoming in any address. Now when I try to bind, this will lock the port for this application. If it fails, I just error out on the runtime error. This is the bind function here. And then listen, which would be I will be listening for new clients to come in. The backlog is basically how many clients I can put on waiting. This can be changed later. So once start finish its basic routine, start worker is called. Start worker will create a thread. This means the main thread will continue running other tasks. And the thread will be static worker. Now in C++, as far as I know, in pthread create, you have to pass a static function so that it's created on a new thread. So I pass the static worker, and I pass the same server object, the instance, through the parameter to then call the worker. So you can see here, this is passed into the param, then the param is casted into CServer, and then server worker is called. That's where the actual worker function is. So the worker will loop and listen for new clients. This use sleep here is actually not required. I'm just going to delete it right now because this accept is a blocking call, so it'll stay stuck in accept, waiting for clients. Now, when the client successfully is accepted, start client is called. So once start client is called, it creates yet another thread, so the listener can continue working on its own thread. So here we have another static client. This is to pass it through and then actually call the object, the class function. So I need to pass more than just the CServer. So I created a CSocket package where we pass the socket. This package inherits INet, which is, so basically it has the networking functions for its inner socket, which is a client socket. And then that's what's passed through the parameter here, which comes here as casted, and then we call the client function, which is this with the package itself. Now going on to the CClient class. The CClient class enters in start worker. it has a worker because it just keeps data synchronized and sends transactions when necessary. So when we start the worker, it creates, well, let's go through start, which is the actual function that's called from the chain. Start creates a socket and then connects to whatever address, which would be the one that we're connecting to. This one here. Wait, no, this one's a host name. This one's the one we're connecting to. We're connecting to this host name. So basically it tries to connect, it fails out if it doesn't, and then it starts the worker. The worker, like I said, same as I said before, calls a static worker with its own instance, calls the worker, sets a timeout, then I have here a flag to stop logging up after the first ping. Now it sends the EMP node register with the host name that was configured in the chain. This is to identify itself basically. Then it sends a port where this other node would connect to it if it wasn't right now itself, you know, so I'm making it connect to itself. And then when it's running, it just pings, and when, you know, if you exit, you know, you interrupt the node, it just exits. Now there are some new functions in chain object. As you can see, the host name is always required. It has to have some sort of identity. So when it registers to another node, it tells the node connect through this host name. Here's a new flag if it's a new chain or not. If it's not a new chain, then it will try to connect to node. This means it will connect to node, another node. Now in this scenario, I'm sending false to test out the networking, and I'm connecting to myself to test out the networking without complicating my life and having to run two instances of this and two different host names. So new functions would include stop, be able to stop the server and clients, and is running. This just tells you if the chain is running. Two getters and connect to new client. This just creates a new instance of a client and connects to whatever host name is specified. Now, when it's not a new chain, it will create a new client connecting to that host name through that port. This port currently I have it static, so all my nodes, but later on we'll make this a little more flexible so each independent node could have different ports, etc. Now, as you can see, it creates a new client, calls a new class, the net class we just created, and pushes back to its list of clients. So how I explained on the PowerPoint, the nodes are distributing into the list. Now, I still haven't added the eMessage type to report the distribution, but that will be done on the next episode. So in our main entry point, I changed this, like I mentioned before, where it creates a chain with himself as a host name and connects to himself. Another thing I added was the interrupt handler. So basically when the interrupt callback, which is this function up here, when you try to interrupt the application, it will call CChain stop, signed here. And this while, which just keeps the main thread sleeping, that we might do other things in the future with. That's it. Now let's test it out. So since we have new files, we're going to call CMake. Again, make sure it adds new files to the make file. On make, so we build it. And now we're going to call the binary, which used to be called simple blockchain, now renamed just to blockchain. So as you can see, the client connected, the server acknowledged the client, the server got the client host name, added the node to list. Here again it says it's the client. Oh, this was because the server received it. I mean the client. So the server has a log and the client has a different thing here in parentheses for the log. Now, the server received the ping, and as you can see, I set the flag so the rest of the pings are silent, so we don't get spammed. And the same thing for the client. Now, when I interrupt, since there's probably data transferring all the time, one of them will probably receive a weird packet and gracefully close. So you can see everything was gracefully closed and the program exit gracefully. So remember to comment and subscribe. Once I reach 1,000 subscribers, I will release the source code on GitHub of this blockchain project, and it will be a lot further down.